$1,000. So that extra child costs her $1,000 of earnings. It reduces her hours by 3. It reduces her weeks by 3. It reduces her LFP by about 8 percentage points. So that's the twins. What about sex mix? The sex mix first stage is over here. If I have a same-sex ship, it increases my probability of having a third child by about 6 percentage points. So basically what happens is, in this sample of younger married women with at least 2 children, people with a mixed-sex ship have about a 37-point probability of having a third child. 0.37 of them go on to have a third child. But then if I have a same-sex, it bumps that up to 0.43. So that's not as good as twinning, but it's still pretty big. It's a pretty good instrument. It's not in the realm of the weaker ones that Jim was talking about in some of the older work, and in some of the newer work that comes up. But in this case, it's a powerful difference, not as large as twinning, but still worth studying. So if you have a same-sex ship, you're 6 percentage points more likely to have a third child. You're a little bit under 1% less likely to be working. You work about 0.38 weeks fewer. You work about a third of an hour less. And you earn $132 less. Now in this case, the reduced forms are smaller than the twins' reduced forms, but the bottom line, the causal effect of having a third child in this case actually comes out to be bigger, because you're dividing by a smaller first stage. So the actual IV estimates using sex mix suggest that the birth of a third child reduces LFP by 13 percentage points, and it reduces weeks and hours by about 5 or 6. It reduces earnings by over 2,000. So that's interesting. I like to put these two together because this helps drive home the point about external validity. These are 2 good instruments. I love them both equally, even though I didn't think of one of them, only the other one, Evans and I thought of. And yet they produce different answers to the same underlying causal question. And so to get into that, we actually have to kind of break out our economic theory hats and think a little bit about the underlying behavior here, and the kind of woman who is having a child as a result of twinning, and the kind of woman who is having a child because she wants a mixed-sex ship. And there's a very neat story that can be told out of this. Evans and I told it to some extent, and it's something that I went back to in a recent paper with a former student, Yvonne Fernandez-Val. The kind of woman who has a child by virtue of twinning is a woman who definitely didn't want that child. She wasn't going to have a third child. But then she had a twin and she got one. She's kind of stuck with it. That's a relatively educated woman. And relatively educated women reduce their labor supply less in the face of increased fertility. And the reason they reduce their labor supply less in the face of increased fertility is they're relatively educated, they're relatively well paid, they can hire childcare. That's what they should do. So that's the story of heterogeneous effects told by example. I have some material here on explaining the theory. I'll go through this very quickly. I don't think I should spend too much time on it. This is sort of the modern framework as I see it for heterogeneous potential outcomes that gives us some of the formal results that help us understand how 2 instruments could produce different things. Notice that doesn't happen in the kind of traditional simultaneous equations framework, because you write down that linear model, constant effects, and it doesn't really matter what instrument you use. So in fact, Wright has a bunch of instruments, and he suggests trying them all. And he doesn't quite figure out 2-stage least squares, but he gets quite close. He says, well, we should average them, and that'll probably be a better estimate. Because in his mind, different instruments are actually estimating the same thing, because it's the same underlying causal relationship. That's not really true in the modern framework. In the modern framework, I'll just explain the notation and then tell you what it means. The modern framework, we think about potential treatment assignments. So we think about not only potential outcomes, but potential treatment assignments. We treat that similarly to the potential outcomes notation. So D1 tells us whether we're going to be treated when the instrument's switched on. D0 tells us whether we're going to be treated when the instrument's switched off. We only ever get to see one of these, but we think that they're both well defined. The causal effect of the instrument on treatment is the difference between D1 and D0. Now, what does that mean? D1 is whether I serve in the military when I'm draft eligible. D0 is whether I serve in the military when I'm not draft eligible. Okay. The assumptions here, sort of in Wright, independence, exclusion, monotonicity. The instrument is as good as randomly assigned. In some cases, it might actually be randomly assigned. So that's like saying draft lottery numbers are independent of potential outcomes and potential treatments. Exclusion, the instrument affects Y only through D. So that's like saying draft lottery numbers affect only earnings only through veteran status. Sex composition affects labor supply only through family size. Exclusion is what allows us to go from reduced form to causal effects. It's what allows us to say the effect of sex mix on earnings is really the effect of family size. Okay? And then monotonicity, which is saying that the instrument can only push us in one way, in one direction. Wright, of course, would not recognize my language, but he would surely understand the second assumption here because he talks about it. Finding factors of a type which shift supply but not demand. That's all about the exclusion restriction. In fact, the other assumptions are implicit in his setup as well. The Lake theorem tells us what comes out of this. What comes out of this is that you don't get a constant causal effect from any particular instrument. You get an effect for a subgroup that Emmons and I in a series of papers call compliers. Compliers are people who get treated when the instrument is switched on and they don't get treated when the instrument is switched off. It comes from randomized trials, that language. In randomized trial, what happens typically is treatment is randomly assigned, but in practice, compliance is voluntary. Doctors talk about intention to treat and per protocol. I assigned the guy to treatment, but he didn't follow the protocol. Okay. So DI is treatment received. That's no longer randomly assigned. Okay. Lake extends that idea, partitions the world. There's people who follow protocol. They get treated when the instrument's switched on. They don't otherwise. There's people who always get treated, always takers and never takers, people who never get treated. IV doesn't tell us anything about always takers and never takers because the instrument doesn't affect them. That's the late idea. In fact, the compliers are a subset of the treated. Okay, so anyway, that's something that we've worked on in a series of papers. Let me show you that that idea of compliance is more than just a metaphor. This actually works for randomized trials, and in my view, this is the right way, no pun intended, the correct way to analyze data from trials. This problem is ubiquitous. I don't know if some of you are following medical research. There's been a series of AIDS trials, AIDS vaccines. It has exactly this problem. Not everybody who's assigned to the vaccine takes treatment. When compliance is voluntary, the as-treated analysis is no better than that ordinary least squares estimate of the simultaneous equations. It's got selection bias. It's potentially misleading. People self-select to treatment. It might be healthier. Intention to treat, which is often what you'll see in clinical reports, that is just looking at the original assignment. The intention to treat is the original assignment. That's too small. It's diluted. And it turns out that there's a very easy fix for this. You use the intention to treat, a dummy indicating random assignment to the treatment group, as an instrument for whether the guy actually got treated. In that case, the laid formula has an especially simple form. The reduced form, which is the difference in outcomes with the instrument switched off and on, is the ITT effect. It's the intention to treat effect. The bottom there, the first stage, is just the compliance rate in the treatment group. Nobody in the control group gets treated. That's typical. Like you can't get that experimental drug. Even in my high school, where you could get many illegal drugs, you couldn't get that experimental AIDS vaccine. So the first stage becomes one-sided. And so IV is just the difference in ITT divided by the compliance rate. It turns out that in that case, late is the effect of treatment on the treated, as if you could know in advance who would be treated and then randomly assigned in the subpopulation. If you could know in advance who would comply with protocol and then randomly assigned in that subpopulation, this fixes the compliance problem in randomized trials. So I think this is a huge result, and this is kind of the frontier of IV now, many years after Wright. I doubt that he would have anticipated the connection with randomized trials because there really weren't any randomized trials in his day. randomization as a tool for causal inference doesn't come big time to the United States until the polio trials of the 1940s. So, and I'll show you a very interesting example here. I have two of them in the paper and in the notes, but I think I'll just show you one. This is a wonderful example. I'll skip this other one, which is kind of run-of-the-mill. A study of the best response to domestic violence. Very interesting social question. How should the police respond to battery? Man is beating his wife or partner. Typically, that's the story. The police are not sure what to do. And the argument goes, you know, should we treat it as a criminal kind of thing? Should we arrest the guy? Or is it a social problem? Is it really something that should be referred to social services without much intervention from law enforcement? And there's genuine uncertainty about this. Many people have strong opinions, but typically the police will say that they don't know. They don't know what they should do. And remarkably enough, there was a very progressive mayor and police chief in Minneapolis in the early 1980s. And they decided to do a randomized trial where they would respond randomly to domestic violence calls. So the cruiser shows up at an address, and it's a case where the victim or a neighbor has called for assistance, called the police. It's a case of domestic assault. The police are unhappy as usual with such cases. They don't know what to do, so they agreed to do a randomized trial. Now this is before the internet and all that. So if you've been arrested lately or pulled over for a traffic offense, you'll know that the police all have laptops and now. But in those days they wouldn't have had. They would have had charge sheets, which are paper forms that they fill out. And they did this by color coding the forms. So the police cruiser who's going to respond to these domestic calls has a charge sheet, and it's color-coded. And according to the color, the policeman is randomly assigned to either separate the parties, refer to counseling, or arrest the perpetrator. Now, in practice, you can imagine that it's hard to actually force an officer in the field to do something in particular. He has to be able to deviate. So this is what happened in the MDVE. You can see in this table, what I've tabulated here is assigned treatment, and delivered treatment. So 91, this is all the domestic violence cases in Minneapolis in the period of a few weeks. Everybody was assigned to be arrested. Almost everybody who was assigned to be arrested was arrested. So 92 people were assigned to be arrested, 92 incidents. The police will arrest the guy. Well, the police know how to arrest people. They're good at it. They arrest you. So 91 times they arrest, almost every time they arrest. Where they deviate from protocol is 108 times they were assigned to advise the parties to refer to counseling. They still arrest 19 of those guys. Maybe because the guy is drunk or violent or it's a particularly dangerous scenario. 114 of those cases, they were assigned to separate. Just say, okay, you have to move off the premises for 48 hours. 26 of those cases are still, the guy is still arrested. So in practice, what's being done is not randomly assigned. In practice, what's being done is highly endogenous in the language of econometrics. The police are responding to conditions as they see them on the ground, and they're not mechanically executing random assignments. What should we do with these data? Well, this MDVE generated maybe a dozen papers in sociological journals and criminological journals, and in the JASA, the Journal of American Statistical Association. And I got interested in this through a friend who's a criminologist, and I started looking at these data, and it occurred to me that what really ought to be done with these data is IV. Now you might say that that's what I always think, but in this case, it's actually true. What ought to be done here is intention to treat, treatment delivered, IV solves this problem. And the simplest way to see that is to kind of think, well, the interesting treatment here is whether you're arrested or not. So I call not being arrested being coddled. So that's the treatment, coddling. And that turns it into Bernoulli, so that simplifies it. Here's the first stage in the reduced form. If you're assigned to be coddled, then 79% of the time you are coddled, but 20% of the time you're arrested. And that's invariant to whether we control for covariance, because it's random assignment. Well, it turns out coddling is bad. If you're assigned to be coddled, then 11% of the time the police have to come back within 6 months. That's the outcome. The police have to come back for another domestic violence call. So the ITT here already looks bad, but it's worse than that. It's worse than that. The reason it's worse than that is that what I really need to do is divide 0.11 by 0.8, and then I get the actual causal effect of interest, which is the effect of coddling on the coddled, and that's almost a 15 percentage point increase in the likelihood of another domestic violence call at the same address. So, ambitious experiment, courageous researchers, somewhat befuddled analysis, very simple solution. IV solves the compliance problem. Also opens the door to other trials like this. You never actually have to randomize treatment. It's enough to actually manipulate people's behavior in some way, and then you're going to have an instrument. But you don't have to come to the ideal of actually deterministically flipping people's treatment. You just have to change the likelihood that something happens, and then you get an instrument. So once I think about doing randomized trials for something like domestic abuse, there's nothing I can't think of studying using experimental methods. So I see this as a very important development and something that's emblematic of recent work. Okay, I should say the other thing here is if I ignore the fact that coddling is endogenous, I get a number which is way too low. And that's because when the police are coddling, the situation is not that bad. So the reoffense rate is low. So in fact, I get the right sign, but I don't get the right magnitude in that case. The right magnitude is about double the per protocol analysis, as it would be called in this case. Okay, so let me wrap up and just make a few more comments to bring it back to why we're here. IB provides a powerful and flexible framework for causal inference on a number of our most important problems. I would say for our most important problems. The core identification problem for simultaneous equations. Problem solved. An elegant solution to the problem of mismeasured regressors. A general framework for controlling or eliminating omitted variables bias. A solution to the ubiquitous compliance problem in randomized trials. And any related research design which has partial random assignment. Philp Wright's path-breaking, and pun intended here, path-breaking analysis, the obscure Appendix B, laid the foundation for progress in all of these areas. These are the problems that define our field. The other thing that I really like about Appendix B, and I actually have a copy here. He doesn't have one. A student of mine found this and gave this to me. It's worth looking at, and I'll leave it here for the rest of the afternoon if people want to look. Wright's work here doesn't emerge from an abstract thing, like he doesn't wake up in the morning like some econometricians might and say, well, today I'm going to solve the identification problem. He wakes up in the morning and he says, I'm really concerned about the effects of these tariffs, which are these tariffs that were passed in the early 20s, which many people think that sort of momentum towards protectionism contributed to the Depression. And he's clearly worried about the economic consequences on very, very high tariffs on things that used to be duty-free. And he recognizes these are intermediate goods that are going into all sorts of industries, and he thinks it's probably going to be a bad thing. And he wants to show it. And he lays out very concrete causal questions about what's this going to do to prices, how much is it going to boost farmer income, which is the motivation. It's really about the farmers and not the oil producers. And would that ever be worth doing? You know, what's the cost of the economy? So his econometrics comes from concerns with economic questions and policy issues of his day. Today's empiricists start with causality and identification, And we also, I put myself in this camp, we think about policy concerns as first and foremost. We do a little better in some ways than a lot of the econometrics that came later. So I thought I would conclude with this. Wright understood what empiricists like me hold dear, that empirical work lives or dies not so much on the mathematics, but on the choice of instruments. And so he talks about success with this method depends on success in discovering factors of type A and B. And actually in the letters we see more on that they are struggling to find instruments for the relationships of interest. And in fact, I was exceedingly pleased to see that and to learn about that, because a lot of the empirical work that came after Wright, and I'm particularly thinking about the period between the Coles Foundation, which is a group that was set up to study econometric methods in the 1940s. A lot of the empirical work of that period didn't seem to have that question of how to identify causal relations, find the center of the credibility of the identification strategy. A good example of this, it's really one of many, there's a paper by Kerry, 1949, kind of early Coles era demand analysis. He's going to estimate a demand equation, and he says, for the instrumental set, we have no fewer than 15 series, which Stone, 1947, numbers 3 to 17. They need not be particularized here. So his instruments are series 3 through 17 from Stone, 1947. If you care to find out what they are, you can go look it up yourself. But of course, he doesn't discuss whether those are good instruments and whether he really succeeds in isolating a good experiment. And this kind of indifference to the details, I have some sense of where it comes from, but I'm still not happy when I see that. The kind of indifference to the quality of the underlying experiment is fairly common in the period of the immediate post-Coles Foundation era. And often the instruments are sort of mechanical, maybe just a lag or something like that. Today, we're back where Wright started. The experiment is where we begin and where we end. Thank you. I was lucky enough to know Samuelson. I overlapped with him for a number of years in the department. He died only last year. And I had lunch with him often. And I have to admit, I never talked to him much about that. He was famous for being fairly hostile to empirical work. There's a quote, some of you may know it more accurately than me, but it takes a theory to kill a theory. Econometrics can only dent the theorist's hide. The damage that any particular set of findings could do would always be very limited. The theory was more powerful. I know that's what he thought. To be fair, he's of a very different generation. And I guess I would say that he might have been right to dismiss a lot of the econometrics of the 40s, 50s, and 60s as not having been worth a whole lot.
There are numerous factors that are five
it's not a science, I guess, in the sense that I can't come up with a set of rigorous principles. But I don't know if it's more of an art. You know, if somebody does a really good experiment, like a real experiment, we say that guy is creative or something like that. We use that kind of language. So, but it is outside traditional languages.
You know that Wright struggled with being interested in this fact he was writing. How have you rethought your results given Jim's work on
Well, I used to think that if I had figured out that, say, a quarter of birth was a good instrument, that interacting a quarter of birth with 50 state dummies, that must be a really great set of instruments, you know, that more is better. And I learned a hard lesson that that's not true. So, but I think I would have said before the weak instruments problem emerged as a topic of research that anybody using IV should show us that page 314 appendix B formula. Covariance divided by variance. Ideally, covariance divided by covariance, the reduced form divided by the first stage. For the one thing that sort of embodies their idea, so draft eligibility being born in an early court. And if anything, you know, at the time I thought that that was just in the interest of showing somebody what was going on in their study. You know, very hands up on the table, very transparent. You can explain it to your mother. The draft eligible guys earn less, they're more likely to serve. You divide one by the other. It turns out that was virtuous for other reasons as well. So I would say the case for that only got stronger. The case for sort of pursuing efficiency, which was the idea behind some of the heavily enriched specifications, like in my paper with Kruger on compulsory attendance, that case got much weaker once we understood that it's no free lunch. I genuinely thought that there was no reason not to use preserving instruments if you had them. I probably just didn't think about it very much. So now we have to think twice about heavily over-identified models. And I can't imagine not wanting to see the sort of just identified page 314